First, okay, so um, you had your exam already? Have you had your exam already? Yes, Wow, still so hardworking, Still come for a seminar after exam. Okay, so this is the notes. You can get the PDF notes from the website also if you don't have the physical notes yet. Okay, so at the start of the notes, right, there is a checklist. So this checklist is basically for you yourself to see whether you have studied everything you need already lah. Okay, now this is based on what most of the schools will ask lah. Okay, so most of the schools basically their exam will only cover chapter 1, chapter 2. We don't have chapter 1 here. We will only focus on chapter 2 in this seminar. So you can check whether or you have studied everything about linear motion, everything about motion graph, about inertia and momentum. So these are the 4 things that we will focus on today lah. Okay, so I will very quickly go through these things first, the linear motion ticker tape, okay? And then we will do some exercises. Then we will come back, I'll talk about motion graph, then momentum, then only we will do some more exercises lah, okay? So we will just try to do as many questions as we can, but we will not finish everything lah, okay? Those that we cannot finish later on, we will upload the answers to, probably will give you a link on the website also, then you can get the answers and you can try the remaining question yourself lah. Okay, so any question you can just ask in the chat, don't need to be shy. So we start with the first thing, right, which is linear motion. Okay, hello. Yeah, sorry, sometimes my Zoom will crash a little bit. Okay, let me just reshare my screen. Okay, right. So yeah, just in time, we just started. Okay, so the first thing that we'll talk about is linear motion equation. Okay, this linear motion equation, sometimes I would just call SUVAT equation because it's made of SUVAT, SUVAT. Okay, so this S stands for displacement, which means how far have you traveled. The U and V are both velocity. U is the starting velocity, or we call initial velocity. V is the ending velocity or the final velocity after everything happened. A is the acceleration or deceleration, meaning you got speed up or you got slow down or not. Okay. And then T is the time taken for the whole incident to happen. Usually it's one whole incident. For example, this car, suddenly he changed his speed. He stepped on the gas, then he increased his speed. That's the situation. Or let's say this car sees something in front, then he brake until he stopped. That is a situation. Okay. So the whole situation, you just get this information. What you need is 3 out of 5. Okay. So if you have 3 of the things, you can definitely get the other 2, right? So these 4 equations here, these are your SUVAT equations, and you realize something, that each of them actually is missing one of the thing one. Okay, so like this one is missing an A, this one is missing a V, this one missing a S, this one missing a T, like that. So depending on what information you have, right, you need to find the correct equation to use. So for example, if let's say today you have S, U, and then you have A, and then you have T. So you need to choose the equation that has S, U, A, T, these 4 things, okay? So you can choose the second one because the other ones all got V, so we cannot use that one now. So we choose the second one. Then you just substitute things inside, okay? So that is how you use the linear motion equation. Okay, the next thing is a ticker tape. So ticker tape is basically you have this machine called the ticker timer, and then the machine just keep on tuck, 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 like that. And then you pull a piece of paper underneath the machine. Then it will form a dot pattern. it'll form a pattern. So this pattern we can use to see, is this thing moving or not? Is this thing moving fast or is this thing moving slow? Is this thing increasing speed? Is this thing decreasing speed? All this we can tell just by looking at the pattern only. Okay, so when you have this strip, right, you will need to be able to calculate the velocity and the acceleration. So velocity is just distance divided by time, or displacement divided by time. So you see they give you this distance of the strip is 8 cm. So that's your distance divided by the time. Okay, how do you get the time for this? You need to get the time by seeing how many jumps do you have. Okay, now don't go and calculate the number of dots. You must calculate how many jumps, because this jump, we call it one tick. Okay, number of ticks is one jump because it goes up, down, that's one, up, down, that's one, up, down, that's one. Okay, so here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 ticks, right? Now, each jump is usually 0.02 seconds. Okay, usually lah. If they never mention anything, right, you assume it is 0.02 seconds. So 10 times 0.02, the total time taken is 0.2 seconds. Okay, so you take the distance divided by 0.2, you get the velocity. Okay, now let's say there is acceleration or deceleration. You need to calculate. First, you need to know the formula for acceleration is v minus u divided by t. Okay, so where does this actually come from? Actually from here, this Suvat equation, you move it around, you can get it. Okay, so v is final velocity, u is initial velocity. Which one is final, which one is initial? You have to look for the arrow. Okay, the arrow will always be pointing to the start. So you see arrow pointing to the left, right? So the left is the start. We can say this is the initial, then the other side is the final, the ending. So if they give you this distance, you can use it to find the initial, which is the distance divided by the time, because from here to here is one jump. Okay, this distance is one jump. And then the final, again, the distance divided by the time from here to here is also one jump. Okay, so distance divided by time, you have initial and final velocity. Then you can put it inside. So once you put it inside already, then this time, okay, now this time is very, very tricky. Many students get this time wrong. Okay, the time they want is not the total time. What they want is the time that you take from initial go to final. Okay, from initial to final, how long does it take? So you see, initial is here, final is here. If let's say you start jumping from A, then B will be jealous, lor. You say, initial we calculate together, no? Why you choose A, why you never choose me, leh? If you choose B, then A will be jealous, lor. Then you cannot stop at P also. You cannot stop at Q, because if you stop at P, then Q will say, final we calculate together or not? Why you choose P? Why you not choose Q? So to be fair, right, we will need to take their center, take their middle. Okay, so here, initial, the middle is here. Final, the middle is here. So from middle, you jump to the middle, 2, 3, 4, 5. Okay, from middle to middle. So like that, you jump 5 times. So that's why the bottom number is 5. Each time you jump is 0.02. That's why how he gets 0.1 is like that. Okay, 5 times 0.02. Yeah, so this is how you calculate the acceleration. Now, there could also be a ticker tape chart, which is something like this one, right? So ticker tape chart is just one ticker tape, then you chop, 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 chop. Okay, every 10 times you chop, every 10 times you chop, or every 5 jumps you chop, every 5 jumps you chop. Okay, But make sure every line is the same number of jump lah. Okay. So this one also you need to find acceleration. Again, V and U. The first strip is always to find initial. The last strip is always to find final, U and V. So this strip, you get the distance, which is 2 centimeters, divided by the time. Now this time you need to know got how many jumps. You cannot, if you cannot count this one, this very, very small one, you go and count the big one. Count the big one, how many jump? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because the big one and the small one sure got same number of jumps one. Okay, so the distance is 2 centimeters, and then the time is 10 jumps. 10 jumps is 0.2, because one jump is 0.02 lor. Okay, final also, final distance is 10 centimeter, and then 10 jumps is 0.2 also. So 10, 50, you got final initial. Okay, now again, the time for the acceleration, again, is a tricky part. So from initial to final, how many times you need to jump? Okay, this whole thing is the initial, this whole thing is a final. So from initial, you jump 1, 2, 3, 4. You jump 4 times ma. Now this 4 times, you need to look, every time you jump is not one box only. Every time you jump, is actually 10 boxes. Every time you jump, you are actually going through 10 of them together. So it's not really 1, 2, 3, 4. It's more like 10, 20, 30, 40. Okay? So that's why the time at the bottom is actually 40, or 4 times 10 times 0.02. Okay, because each jump is 0.02. Every time you go over the building, is 10 jumps already. Okay, so total is 0.8 seconds. Yeah, that's how you get the acceleration of this thing. Okay, all right, up to here. Any questions or not? Anything that you don't understand before we go into one of the exercise? Okay, all right, we try question number 1. This is on page number 7. Okay, page number 7, question number 1. So here there's an experiment, and this experiment is to discover or determine the gravitational acceleration of a falling object. When something is falling down, what is the acceleration? That's what we're trying to find. So this thing will be pulling a ticker tape when it fall down. So you pull the paper, and then the paper go ta 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 like that. Okay, then this is what we get after we cut to get the ticker tape chart. So the ticker timer vibrates at a frequency of 50 hertz. Now 50 hertz means what? Hertz means per second. 50 hertz basically means 50 jumps or 50 ticks per second. 1 second, 50 ticks. So that means 1 tick is how much? If 1 second is 50 ticks, 1 tick will be, you divide by 50 lor. Divide by 50. This one also 1 divide by 50. You get 0.02 seconds. So that is how we got this number just now. In case you're wondering why one jump is always 0.021, it's because most of the time we use 50 hertz. Okay, so they ask you, first question, what is the time of motion for each strip? This is 1 strip. So they're asking you, what is the time taken for 1 strip? Now, this strip is not 10 jumps. It's not 5 jumps. Every strip is only how many? See from the bottom, 1, 2. Okay, 1, 2. 1, 2. Every strip is only 2 jumps. So the time is 2 times 0.02. That is 0.04 seconds. Okay? That is the time taken for each strip. Okay? Next, explain why the ticker timer is connected to an AC supply. Okay, so you see this thing connected to this, which is AC. Okay, for those that don't know, AC and DC are the two different kinds of electricity that we have. Stands for direct current and alternating current. Okay, now direct current means that the electricity always go in one direction only. Okay, like a battery. But alternating current, the electricity will always switch direction one. Okay, it's like you keep on switching the battery direction. Left, right, left, right, left, right, left, right. It keeps on switch direction. So why must the ticker timer connect to the AC is because I need it to keep switching direction. Because I need it to go up, down, up, down, up, down, up, down, up, down, up, down, like that. If it's just DC, then it will just pop up and then stop there. Or it will just down and then stop there. Okay, so I need it to keep changing direction. So you can say, to allow the ticker timer to move up and down. Okay, to allow the ticker timer to move up and down. Right? So the next one, you have to find the acceleration from this. Okay, so we start from the formula first. Acceleration is v minus u divided by t. Okay, so vu is the final and initial velocity. Again, the first strip is always used to calculate initial. The last strip is always used to calculate final velocity. So velocity is distance divided by time. The distance of the first strip, 2 cm. Okay, so I put it, I write it somewhere at the side first. U is 2 cm divided by the time. Now we already know that one strip, the time is 0.04. Okay, yeah, because it's 2 jumps. So every strip, 2 cm, right, is 0.04 seconds. Okay, so 2 centimeters divided by 0.04 is it's like 200 divided by 4. So it's 50 cm per second. Okay, 50 cm per second. Now, then I calculate the V using the last strip. How long is the last strip? The last strip is 8 centimeters. So the distance is 8 cm divided by the time taken for that strip is still 0.04 seconds. So 8 cm divided by 0.04 is 4 times this answer lah. Right? So it's 200. Okay? 200 cm per second. Yeah? So now I can put the V and U inside my formula. So the V200 minus the U50 divided by the time taken. Okay, so time taken for this is when you go from initial to final. Okay, initial to final, let's see how many times you jump. This is 1, 2, 3, 4. Correct or not? It's 4 jumps, right? 4 jumps. But remember, every building you jump off, you are not jumping off just 1 only, you are jumping off 2. So it's more like 2, 4, 6, 8. Like that, you know? Okay? Yeah? 2, 4, 6, 8. So basically it's like 4 times 2 times 0.02. But you already know one strip is 0.04, right or not? So if you jump over 4 strips, then you can just put 4 times 0.04. Okay, since you jump over 4 strips, and I know each strip is 0.04 anyway. Okay, so this will be 150 divided by 0.16. Okay, can you calculate what is 150 divided by 0.16? How much is 150 divided by 0.16? Oh, no calculator. Your phone can calculate. Phone got not. 150 divided by 0.0016. Okay, 937.5. Okay, so this one, right? Up here is CMS -1 because it comes from here. CMS -1, CMS -1 divided by S. So it'll get me CMS -2. Okay, but later on, they will want me to compare with this. So I'm going to change it to meter per second first, since I know they're going to ask me to compare later on anyway. So to change to meter, you just have to divide by 100. 9.375. So 9. Let's say 38 meter per second squared. Okay, 9.38 meter per second squared is the acceleration of this thing. Okay, the next one. Acceleration due to gravity on the surface of Earth is 9.8 meter per second squared. What does it actually mean? Basically, they're asking you, right? What does the acceleration actually mean? Like when I say acceleration is 9.8, it means what? So acceleration means that you are going faster and faster, right? Your speed is increasing, your velocity is increasing. But how much is it increasing? It's increasing by 9.8 log. Okay, so that means your speed will be like starting from 0, it'll be 9.8, and then it'll be like 19.6, yeah, and then it'll be like 28.4. Okay, it's all plus 9.8 plus 9.8 plus 9.8. Okay, yeah, so that is what it means. Your speed will increase by 9.8 every second. So you say the velocity increases by 9.8 meters per second every second. Okay, while falling. Yeah, if you fall due to gravity, your speed will increase by 9.8 meters per second every second. So that's why 9.8 meter per second. That's how you get the per second square. Okay, but this statement, this increase by 9.8 is only true if you are falling due to free fall. What does free fall mean? Free fall means, right, you fall because of gravity only. You don't have any other forces, especially like resistance or friction, all don't have. Okay, you are falling due to gravity only. So you say falling due to gravity only. Okay, or you can say no resistive forces. There are no other forces. Actually, no resistive forces, no other forces also can. Basically, you are only falling because of gravity. Then only you can get 9.8. Okay? But in real life, you don't get 9.8 in real life. Yeah, you don't get that. Because in real life, you will be lesser. Like in this example, I've calculated when the thing fall down, the acceleration is only 9.4 instead of 9.8. Okay? Because in real life, there are other forces, right? So that's what they're asking you here. Give two practical reasons, explain why the value that calculated is less than 9.8. Okay? So first thing first, when this thing fall down or when anything fall down on Earth, why it cannot fall at 9.8? Because there's always air resistance. Okay, there's always an air blocking. Yeah, so you say air resistance on the weight. The object is called the weight lah. Yeah, this thing here is called the weight. Right? There's air resistance on the weight. Okay? But they want two reasons mah. This is only one reason only mah. So what else, right, is stopping the thing from going down smoothly? What else is stopping the thing from falling down smoothly? You remember, this thing, right, is pulling a ticker tape. Right or not? So the ticker tape, when it goes through the ticker timer, there is confirm some friction there, one. There is surely some friction there whenever you're pulling the tape like that. Okay, surely got some friction there. So you can say friction between ticker tape and ticker timer. Okay, friction between ticker tape and ticker timer. Okay. Now, I'm going to repeat the experiment on the planet with a gravitational field strength twice the value of Earth. Meaning, when I do the experiment, right, and I calculate using the ticker tape chart, I should expect to get double this number. Okay? Now, how do you get double the number? You see, if you want to get double the number, this difference between V and U must also be double. You see, now it's 150 divided by 0.16, right? You get 9.38 ma. If I get 300 divided by 0.16, then you get double because the difference is double. So how to get double the difference between this U and V? Okay, how to get double the difference? You can basically double everything. Because you see, now there's this difference, but if you double everything, this difference will also double together. Okay, if you don't believe, right, we can try. You see, this is 2, 4, 2, 4, 5, 6, and 8 ma. So imagine if we double everything. Okay, so the first one, 2, right, we double to 4. Okay, we double it to 4. Yeah. And then the next one is this 3? I think this is 3. Let me just draw it. Okay, yeah, this is 3. So 3, we double it to 6. Okay, we'll double it to 6. All right. And then what's the next one? The next one is 5. So 5, we double it to 10. Okay. And then the next one is 6. Okay, the next one is 6, we double it to 12. Okay. And then the last one is 8, so we double it to 18. Oh, sorry. 8 double it to 16. Okay, of course you use ruler to draw lah. I just lazy to use ruler only. Okay, so the middle one doesn't really matter one. Actually, the middle one is not the main point because what our main point is the U and the V only ma. The difference between U and V only ma. Okay, so you see the U and the V, right? The difference here is 2 and 8 ma. The difference is 6 difference ma. So if we get the difference of double that, then we can get double the acceleration already. So you see this one, the difference is 16 and 4. That's 12. Okay, so 12 is the double of 6. So then we will get double the acceleration. Okay, so that's what we expect from the ticker tape chart. Okay, yeah. Now, if you cannot copy in time, right, it's okay. Later on, we give you the answer so you can copy in time. Also, you can slowly copy. But most importantly is you need to understand what I'm saying first. If you can understand, then no problem already. Later you see the answer, you will also get it one. Okay, now let's talk about let's look at the next question. Okay, which is a Suvat question. So here we have a car and a lorry of different masses approaching a zebra crossing with velocity of 20 meters per second. So both of these they're both moving at 20 meters per second together. When the driver of both vehicles saw City, this is City, okay, crossing the zebra crossing, they applied brake simultaneously, means together, until both vehicles stopped completely. Okay, first question, what is meant by mass? So we know that there are actually mass and weight. These two are actually different things, okay? Mass is basically how much things you have inside you. Okay? How much things you have inside you. And this doesn't change one. No matter where you go, the amount of things, right? The amount of cells, the amount of fat, the amount of oil inside you is the same, no matter where you go. But weight is different. Weight depends on the gravity. So you go to somewhere with different gravity, then you get a different weight. Okay? So how do we say the amount of things inside you? You can say the quantity, okay? The quantity of matter, yeah? Quantity of matter in a body. A body is an object, right? Quantity means how much. Matter means things. How much things in an object. That's the meaning. Okay, so a lorry and a car, which vehicle will stop completely first? It's okay. Welcome, welcome. We are just on our second question only. Okay, so a lorry and a car, right? Which will stop completely first? I mean, your logic, your common sense will tell you it's going to be the car. Okay, now, why is that? Now, this is something that is called inertia. Okay, it's not up there in the notes, but it's in the checklist. So just very briefly, inertia means that the object, right, wants to maintain what he's currently doing now. Okay, the object wants to maintain what it's currently doing. If it's moving, it wants to continue moving. If it's not moving, then it will want to continue staying there. Don't move. Okay? So why can the car stop faster? Because a car is smaller mass. Okay? And the mass affects the inertia one. You see, both of this lorry and car, right? They are both moving. So their inertia will say, keep moving, keep moving, keep moving, keep moving. But because the car has a smaller mass, it's easier to fight the inertia. Okay, he want to keep moving, but the brake say, no, stop. So the car, okay, stop. Okay, but the lorry, right? The lorry has a very big mass. So the lorry's inertia will be like, keep moving, keep moving, keep moving. Even when the brake says stop, also the lorry say, keep moving, keep moving, keep moving, like that. So that's why the lorry is harder to brake. Okay, so we can say car has smaller mass. Okay, the car has smaller mass, smaller inertia. Okay, so it is easier to stop. The car has smaller mass, smaller inertia. It is easier to stop. Okay, now if let's say both of them are not moving already, both of them are stopped already, then their inertia will say, don't move, don't move, don't move, don't move. But for the car, because again, he has a small mass, so the car engine say, move. Then the car will be like, okay, I move. Okay? But the lorry has a big mass. So his inertia will say, don't move, don't move, don't move. So when the engine say, move, the lorry also say, don't move, don't move. So the lorry is harder to start moving. Okay? When they are both stopped. Yeah? So work both ways. If you are harder to stop, you are harder to start also. Okay. If the lorry has traveled 375 meters before stopping, calculate the acceleration when the brake was applied until it stopped. Okay, so this, right, is a SUVAT question. How do you tell? If you see the question, right, got talk about distance, got talk about acceleration, got talk about time, got talk about velocity. When you see at least two of these things together, right? Distance, velocity, acceleration, time, you see two of these things minimum inside the question, you can start to assume it's a SUVAT question already. You can start to try doing it as a SUVAT question already. Okay? So for SUVAT, we will write down SUVAT first to see what information we have. The S is how far we are traveling. Okay, how far we are going. So we go 375 meters. Okay, initial velocity. Before the brake applied, before the brake, right, they are both traveling at 20 meters per second. So that's your initial velocity. 20 meters per second. Okay, the final velocity, because he brake until where? He brake until it stopped. So that means your final velocity must be 0 because you brake until you stop, right? The acceleration is what you're trying to find out. Calculate the acceleration. Okay. Now the time taken for all this to happen, we don't have. It's not given, but we don't need it actually because, like I said, once you have 3, you will get the other 2 one. You can calculate one. It's a buy 3 free 2. Okay, so even if you don't have the T, also never mind. So now I got SUV, and I'm trying to find A. Okay, so I need an equation that has S, U, V, and A. Okay, so back here, which one got S, U, V, and A only? You can see this one, right? Got S, U, V, A, no need T. So let's write this equation down. V squared equals to U squared plus 2AS. Okay, V squared equals U squared plus 2AS. Right? So put in the numbers. 0 squared equals to 20 squared plus 2 times A times 375. Okay? So 0 squared is of course 0. Yeah. I don't write 0 lah. I write 0 lah. And then 20 squared is 400. 400, right? I bring it to this side, it become minus 400. Okay? 2 times A times 375. You can calculate lah. Okay, so this is 0 minus 400, yeah. So can you get what is A for me? How much is the A? Calculate A for me. Negative 0.533. Okay. Oops. Negative is very important. All right. Negative 0.533. Is the negative correct or not? Yes, it's correct. It's supposed to be negative because A is acceleration, speeding up. So now we are slowing down. You need to have negative acceleration, which is deceleration, slowing down. Okay? So yep, negative 0.533 is the acceleration. Okay, next. Why do the authorities set a maximum speed limit of 70 km per hour in urban areas, but 110 km per hour in the highway? Urban means in the city, inside the city area. Okay, why in the city area must be slower, but highway you can go faster? Okay, because inside the city area, this is just common sense only. Inside the city area, there are many things that you need to stop, right? You have like people zebra crossing, okay? You can have a traffic light, you need to stop. So if you go very fast, it's very hard to stop, okay? So in the highway, you don't need to stop, so you can just go fast only, okay? So that's how we will say it. You can say urban areas have obstacles. Urban areas have obstacles, means things that stop you, that require the vehicle to slow down or stop. Okay? Urban areas have obstacles that require the vehicle to slow down or stop, such as intersections. Intersection means like the road crossing. Okay, road crossing means intersection. Traffic lights. Traffic lights and zebra crossings. Okay, intersections, traffic lights, and zebra crossings. Okay, Ken? All right, so now let's go on to the motion graphs. Okay, yeah, we've done ticker tape, we've done Suva. Let's look at the motion graph. Okay, so motion graph is basically a graph, right, to show how something is moving. Is it moving or not? Is it moving fast? Is it moving slow? Is it going faster? Is it going slower? Also, we can find out from this graph. Okay, so you need to know how to describe the motion graph to them. For example, like let's say you see this question here, like they'll say, oh, describe the velocity and the acceleration of the car when moving from like this. So whenever you describe motion graph, right, you have to have three things. Is the object moving or not? Okay, stationary, then stationary. Is moving, then you have to write the word moving. Where is it moving? Is it moving forward? Is it moving backwards? Is it moving in the opposite direction? Okay, and how is it moving? That's the most important part. How? Is it moving faster and faster? Is it moving with a constant velocity? Okay, So all this you need to be able to answer, right? Then you can know how to describe the graph. Okay, so we have two kinds of motion graph, displacement time and velocity time. Displacement time shows you at every second, where is the object? Is it close to your home or far away from home? 0 is your home, remember. This 0 is your home. So if you're going up and up and up and up, means you are further and further away from home. If you're going down and down and down and down, means you are coming back home. So you see moving backwards, coming back home. Okay? If you maintain the same distance, 10 meter, 10 meter, 10 meter, 10 meter, that means you must not be moving, because you keep on at the same distance from your house, okay? So if it's a straight line, right, it means that your velocity is constant. It's a fixed speed. Why? Because for this displacement graph, the steepness, the gradient is actually the velocity. So if your gradient is fixed, that means your velocity is fixed. Then what about all this curved graph? For the curved graph, right, you need to see what's happening to the gradient. Is it getting steeper and steeper? Is it getting flatter and flatter? To answer that, you just sit on the roller coaster and then you start to go. Okay? So like this one, is steeper and steeper. So that means your velocity is faster and faster. You are accelerating, increasing velocity. You see this example here also. From like that, then you go to, you see, this is very steep, steeper and steeper. So this is also acceleration, faster and faster. But this one goes from like that to become flat, 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 flat. So this one is flatter and flatter, is a decreasing speed. Okay, it's a deceleration. Yeah, same for this one now, it gets flatter and flatter. Okay. Now for the velocity time graph, right, is telling you every second how fast are you going? What is your speed? If you see the speed going up, that means you are accelerating. If you see the speed going down, that means you are decelerating. And one more you can add on. If you see that the speed is like this, a straight line, constant, this actually means you are moving. Okay? Don't think that because it's a straight line, that means you are not moving. It is moving because you have a velocity. It is moving. Okay? Now, again, the curved lines just tell you, is your acceleration getting more and more, or is your acceleration getting less and less only? Again, just sit on the roller coaster and see whether it's getting steeper or it's getting flatter. Okay? Now, this one is very, very important for calculation because the question is not going to ask you to describe only. The question surely will ask you to calculate something one. So this must remember. Okay? What is this? SVA. The S is displacement or distance. We don't really care which one. We just either one. The V is velocity or speed. Again, we don't really care which one. A is acceleration. Okay? Yeah? Or deceleration. Now, so the way it works is like this. If you need to go down, then you need to find gradient. If you need to go up, you find area. Okay? Go down gradient, go down gradient, go down gradient. Okay? So imagine the question, right, gives you a velocity time graph. And they ask you for what is the acceleration. So what did they give you? They give you this. What do they ask for? They ask you to go down. So they ask you to go down, you find the gradient for them. If they ask you what is the distance traveled, what did they give you? They give you this. What did they ask you to find? They ask you to go up. So you find the area for them. Okay? So that's how you use this shortcut. It's a very important shortcut, right? SVA. So we can try Try doing this. Yeah, so you can look at question number 7 on page number 17. Okay, question 7 on page 17. Okay, here we have a velocity time graph. What is the acceleration of the particle in the first 3 seconds of the motion? Okay, again, I write down my SVA first. Go down, gradient. So that means up must be area. Okay, what did they give you? They give you velocity time graph. Okay, what are they asking you to find? They are asking you to find acceleration in the first 3 seconds. So where do you have to go? Go down. So that means you need to find the gradient for the first 3 seconds. This gradient, basically. Okay? Acceleration is the gradient. And you know how to calculate gradient, right? y2 minus y1 over x2 minus x1. Okay? So y2, you can put 15 minus 0. x2, 3 minus 0. So 15 divided by 3, 5. Okay, and because it's an acceleration, that's how I know the units is ms -2. Acceleration is 5. Okay, what is the deceleration of the particle after 3 seconds? Again, they give you what? They give you v. You are at v already. What are they asking you for? Deceleration. They are asking you to go down again. They're asking you to find the gradient again. So you need to find the gradient again, but for after 3 seconds. So the gradient of this line. Okay? So gradient, again, y2 minus y1 over x2 minus x1. You don't, the point 1 and 2, right, is not fixed one. You don't need to fix the point must be here and here. You can choose here and here also. You can choose here and here also, up to you. So I'm going to choose this point and this point as 1 and 2. So my y2 minus y1, 0 minus 15. x2 minus x1, 6 minus 3. Okay? Negative 15 over 3, negative 5. Negative 5 ms negative 2. Okay, so now what is the total distance traveled by the particle? Where are they asking you to go? They're asking you to go up. Find distance, ma. Distance is up here, ma. Right? So you have to go up. So go up means you need to give them the area. Okay, distance is basically the area. Area of what? Area of the graph. Now let me show you where is the area of the graph. Area of the graph is this. Okay, this one. And this one. Okay, these two are the areas of the graph. Okay, so let's calculate. Is this triangle only? You should know how to calculate triangle, right? This plus this. Okay, so the first big triangle, half times the base. Base is 6 times the height, 15. Okay, plus this one also half times the base, 6 to 8, the base is 2. And then the height is 10. Now, why I don't use negative 10? Because distance is a scalar quantity, meaning distance doesn't care about positive or negative. Distance doesn't care about direction. Okay? It only cares about total, how far you go on it. But later when you do displacement, then yes, you must care about positive and negative. Okay? Because displacement is a vector quantity. Right? This one got no positive or negative. Okay? So I don't care. I just want a number. Right? So half times 6 is 3. 3 times 15, 45. Half times 2, 2. This one is 10. 55 meters. That's the total distance traveled by the particle. Okay. Next, find the displacement. Okay, so now you are doing the exact same thing because displacement also means go up, also means find area. But remember, there's positive and negative now. So everything is exactly the same, except when there is a negative, I must put the negative. Okay? So this is equals to 45 minus 10. $35 meters. Okay, so that's the difference between distance and displacement. Yeah. Okay, now sketch the corresponding acceleration time graph of the particle. So now we have to make our own graph. Basically, we have to convert the graph from velocity graph to acceleration graph. Okay. Now you start by drawing the frame first. Always make sure you leave room for negative, because you never know whether the thing will go negative or not. Okay, always make sure you leave room for negative. So this is acceleration time. Don't forget the units. They might penalize you if you don't put the units in. Acceleration is meter per second square. Time is seconds. Okay, now, when you want to convert any graph, you draw the same time as them. For example, if let's say right now, my VT graph is like that. They give you 5 seconds, 10 seconds, and then 20. So like that, like that, like that. When you want to draw the acceleration graph, right, you also do the same thing. 5, 10, 20. Okay? You just need to have the same timeline with them. So their timeline is 1, 2, 3, 4, 5, 6, 7, 8. I also draw 1, 2, 3, 4, 5, 6, 7, 8. Okay? Yeah? I also draw 1, 2, 3, 4, 5, 6, 7, 8. And then their timeline is something happened at 3 and something happened at 8. So later also we should know something's going to happen until 3 and then something's going to happen until 8. Okay? This one you can don't draw first. I'm just going to draw it out. So later better for me to draw. Okay? All right. Now let's see. For the first 3 seconds, the first 3 seconds, your acceleration is 5. Okay? So we're just going to draw 5. Okay? Now, from 3 to 8 seconds, after the 3 seconds, the acceleration is -5 from 3 to 8. So that's what I will draw also lah. -5. Okay? This one, -5. Now, here, when you want to connect them together, you can, it's up to you. You want to draw dotted line also can. You want to draw solid line also can. Okay, it's up to you lah. Right? Dotted or solid line doesn't really matter. Okay, so this is the acceleration time graph from here. Okay, can? Okay, let's take a short break. Now it's 5:06, right? We will take a short 4-minute break and then we will come back at 5:10. Okay, you can go and pee, you can go and drink water, okay? Because I also want to go and pee. So we come back here at 5:10, okay? Right? Okay, so now we're going to talk about momentum. Okay? Right, we're going to talk about momentum. This is on page number 5. So momentum, right, actually doesn't have a proper definition. Okay? Momentum is just mass times velocity. That is its definition. That is its formula. Okay? So we will say product of mass and velocity. Product of means multiply together. Okay? Mass and velocity. So when we learn momentum, we also need to learn about something called the principle of conservation of momentum. And according to this principle, right, basically the total momentum will always be conserved. Okay? Conservation, conserve means remain the same. Yeah? So the total momentum must remain the same. Total momentum of what? Okay, so imagine two things, right? They each have their own momentum. Correct or not? This person's momentum is his mass times velocity. This person's momentum is his mass times velocity. When you add up their momentum together, right, that is the total momentum. For example, 5 plus 3, that's their total momentum. Okay? So if let's say they bang together, they knock together, their momentum will change. Okay? Just now it was 5 and 3, right? Total is 8. So now maybe the momentum changed to 2. Then this must be 6. Because when you add them up together, it must be the same as before. Okay? It must still be 8. Yeah? So that's the meaning. Total momentum must remain the same. And from there, we are able to get this equation. Okay? M1U1 plus M2U2 equals M1V1 plus M2V2. Right? Now, there are few ways for things to bump together. Number one is elastic collision. Collision means bang together. Elastic collision means toing toing is elastic. You hit together, toing, you will separate. Okay? Inelastic means no toing toing. Yeah? Inelastic, you hit together, you will stick together. And explosion means kaboom, right? Means you start together, not moving first, and then kaboom, you separate. Okay? Now, each of these, right, seem to have their own equation. But these equations all come from the first one. So I personally don't care about other equations. I personally just use the first one to solve every momentum question. I don't care about this. I don't care about this. I only care about this only. Okay? Yeah? Now, when we talk about explosion, right? Okay, we will come up with many applications of it. And you need to know how to explain this explosion occurring. So according to explosion equation, according to the principle of conservation of momentum, when something goes down, something else must go up. When something goes forward, something must go backwards. When something goes left, something must go right. That is explosion. Okay? Yeah? So boom, always go in opposite direction one. So that is when you need to explain how does a squid work, how does a gun shooting a bullet work, how does a jet engine work, how does rocket work. Okay, but we will cover this later on. For now, let's try to do a momentum question first. So you can go to, let's say, page number 10, right? You go to page number 10, okay? Oh, give me one moment. Let me reply for dinner first. Okay. So here I have two trolleys, A and trolley B. Okay. So trolley A is sliding down, right? I'm just explaining what the question says only. Trolley A is sliding down with a velocity. Trolley B is not moving. Trolley B initial velocity is 0. So later on, when they hit each other, right, A and B will stick together. Okay, they will combine. This is the ticker tape for trolley A. See, they can combine many different things together into the same question one. Okay, the ticker tape runs on the frequency of 50 hertz. So if you remember, 50 hertz means one tick is 0.02 seconds. Okay, what is meant by momentum? This is their favorite question to ask. If your exam got asked you about momentum, right? Very high chance they will ask you what is the meaning of momentum also. Their favorite question, I don't know why. Okay, so you just tell them momentum is mass times velocity. Okay, so the product of mass and velocity. Okay, product of mass and velocity. Okay, next question. State the physics principle. If I see the question is about momentum, and I see them ask me physics principle. Actually, I won't even read the rest of the question already. I already know the answer already. It's gonna be principle of conservation of momentum. Don't write conversation, conservation. Okay, because momentum only got one principle only. So if there is a question is about momentum and the question asks for physics principle, confirm is gonna be this one already. There's no other principle already. Okay. Complete the following statement by underlining the correct phrase in the bracket. The trolleys in diagram 5 undergo a process of what? So remember, elastic means toing toing, hit then toing go apart. Inelastic means no toing toing, heat will stay together. Okay, explosion means kaboom. So this one, after heat, stay together. This is inelastic collision. Okay, calculate the mass of trolley A if trolley B has a mass of 2 kilograms. So now it's the calculation part already. So we're going to use the formula. Okay, now do you know where does this formula come from or not? This M1 U1 one? Actually, basically, it's just this person's momentum, mu, this person's momentum, mu. Okay, this is person 1, person 2, right? So mass times velocity is momentum, mass times velocity is momentum. So add together their total momentum. This is total momentum before they hit each other. Then after they hit each other, this person's momentum add together. So this is after they hit each other, the total momentum. So remember, we say total momentum before must equal to total momentum after, right? So we write down M1 U1, M2 U2. Okay, maybe I write A and B lah. I don't write 1 and 2 lah, because the trolley is called A and B . So mu for A plus the momentum for B equals to the momentum of A plus the momentum of B. One is before, one is after. Okay, so the mass of A is what we are trying to find. We don't know. What is the initial velocity of A? Initial velocity, we need to look at the ticker tape. Okay, we have to get it from the ticker tape there. So this ticker tape, right? This is initial. Actually, don't ignore the AB. This is before hitting. This is after hitting. This is during hitting. Okay, before, during, and after. So before, this is the velocity. Distance divided by time. Okay, distance divided by time. The distance, right? 10 cm. I'm going to put it in meter per second, just in case. Because when I calculate all these other things, usually I use meter per second one. Okay? Technically, if you forgot to change, right? Technically, you should get the same answer also. But just in case, I'm just going to change to meter. Okay? So 10 cm is 0.1 meter. How many seconds? Let's see. 1, 2, 3, 4, 5. 5 jumps. Every jump is 0.02. So 5 jumps times 0.02 is 0.1. Okay? 5 jumps times 0.02. Plus, the mass of B given to you is 2 kilograms. The initial velocity of B at the start, right? B is not moving on. Initial velocity is 0. Okay? Mass of A, the final velocity of A, let's see, after it hit, that's the final velocity. Distance, 3 cm, so that's going to be 0.03. Again, change to meters. Divided by, okay, let's see. 1, 2, 3, 4, 5, 6. 6 jumps. 6 jumps, each jump is 0.02. So the total time is 0.12. Okay, 0.12. Plus the mass of B is 2. Okay, the final velocity for B. Final velocity for B, right? A and B combine at the end. Can A run fast and then B run slow? Or A run slow and B run fast? Cannot, right? We are combined together, means we must walk together, we must run together, we must be the same speed, we must be the same velocity. So actually the final velocity for B, right, is the same as the final velocity for A, since they are together. Okay? So 0.1 divided by 0.1 is 1. 2 times 0 is 0. What is 0.03 divided by 0.12? Calculate that for me. 0.3 divided by 0.03 divided by 0.12. How much? .25. Okay. So this is 0.25 MA plus 2 times 0.25. Okay, which is 0.5 lah. All right. So this, all those with MA, right, I move to one side. All those without MA, I leave in the other side. This is 1 MA. You take this 0.25, you bring over there, it becomes minus 0.25. It's like 1 MA minus 0.25 MA. Okay? So you will be left with 0.75 MA. Okay, just like 3x minus 2x is going to be 1x. So same thing lah. 1 MA minus 0.25 MA is 0.75 MA. Equals to 0.5. Okay? Can you get what is MA for me? 0.5 divided by 0.25. Oh, sorry, 0.75. 0.5 divided by 0.75. 0.66. Okay? So 0.66 kilogram. Yeah, that is the units for mass. Okay, that's the mass of A. Now, the next part actually we didn't cover just now, okay? But I just quickly let you know that impulsive force is the force when something hits something. Okay? Impulsive force is when you have a pop, you hit something, then you have a force. Okay? And there's a formula one for impulsive force is F equals to mv minus mu over T. Okay? That is a formula for impulsive force. So the M, we're going to talk about impulsive force on trolley A. So we will use the details for A. Okay? The mass of A is 0.66. The final velocity of A is, what was it again? Here, 0.25 minus the mass of A again, 0.66, okay, times the initial velocity of A is 1. Okay, initial velocity of A is 1. So this thing divided by the time. Okay, now this time again is a bit special. Okay, because I said impulsive force is the force when you hit something. So this time, right, is basically the time of you hitting the thing. Get it? The time of you hitting the thing. So you see, this is the time before you hit. This is the time after you hit. So this is the time during you hit. So I need this time, the time of you hitting the object. So I need the during. 1, 2, 3, 4. Okay? The time for hitting the thing is 4 times 0.02. Okay? 4 times 0.02. Yeah? So this one is equals to what? Come, 0.66 times 0.25. Do we need to use the jumps on tick to tick? Basically, this one, like that. This one jump is one tick. This is a dot. So from dot to dot is one tick. It's considered one tick. You mean between their middle, like that? No need. This one no need. Because I just need to know the time during only, like that only. So this one is a bit different one, impulsive force. So it's different from like previously when we want to find the acceleration, all that. Okay? If we want to find acceleration, you need to get the middle. You see, this one is an initial, you get the middle. This one is a final, you get the middle. So you go from middle to middle to middle to middle to middle until this middle. If you want to find acceleration for this. Okay? All right, what is 0.66 times 0.25? 0.66 times 0.25, 0.4 something. 0.1 something. 165 minus 0.66 divided by 0.08. Okay, you calculate this. It's going to be a negative number again. But negative number is okay, because force can have positive and negative one. Okay? The positive and negative on the force is just which direction only. Push or pull only. So how much is this? 0.165 minus 0.66 divided by 0.08. Negative 6.1875. Negative 6.19. Okay? Yeah? Negative 6.19. Yeah? All right. Now, I'm not going to do any of the essay questions today, because I noticed that for those schools that already had the exam, because I know some schools already finished the exam already. So for those exams, right, I realized that they never ask essay question. Okay, which is all this, you need to tell them what to choose one. So I'm just going to skip the essay question. Later, when you get the answer right, you just look through the essay answers. Okay, because most of the time for essay, once you see the explanation, you should be able to understand already. Okay, so I want to focus more on the calculation question, lah, right? So let's look at oh yeah, I haven't do the explanation yet. You go to this one, page number 18, 18. I haven't do an explanation one. This one is a theory question. Okay, it appears as a subjective question, right? So I'm not gonna do the principle of conservation of momentum lah. Oof. Okay, so how does the jet engine work? You need to explain. 3 marks, 4 marks question using momentum, right? Now, this explanation, you can use it not just for jet engine. You can use for rocket, can use for gun shooting bullet, can use for squid shooting ink, okay? So the key here is to know what are you shooting out and where, okay? So a jet engine, right, how does it work? A jet engine works by getting the fuel inside the combustion chamber and then burning the fuel. When I burn the fuel, I get a lot of hot gas. You see, this question even tell you there's hot gas already. So the hot gas will shoot out the back. Okay, the hot gas shoots out the back. So we start from there. Okay, now, normally I would just say the hot gas comes out from the back like that. But maybe I can add one more sentence. This is optional. It's optional. I add one more sentence, right, to tell them where does the hot gas come from? Okay, so that at least they won't suddenly think, hey, why got hot gas one? It's an engine, ma. If let's say like a squid, of course you know a squid will shoot ink. But for engine, why is there hot gas? So we tell them first. Okay, so we say fuel is burned in the combustion chamber. Fuel is burned in the combustion chamber to produce hot gas. Okay? Fuel is burned in the combustion chamber to produce hot gas. Okay? Now again, this is optional only. It's only certain questions you need to explain this. All right? Now the real explanation begins. So you start like this. You say that the hot gas is exhausted or ejected. Okay, don't say exhausted lah. We use ejected because ejected can use for other things also. Hot gas is ejected backwards. You shoot to the back one ma. Backwards at high velocity. Okay. Hot gas is ejected backwards at high velocity. Okay. This produces a large momentum, but in what direction? In the backwards direction, because it's moving backwards. This produces a large backwards momentum. Okay. Now, according to our principle, what principle is that? According to the principle of conservation of momentum. Okay, according to the principle of conservation of momentum, when something goes back, there must be something going front. There must be an equal but opposite forward momentum. Okay, because something was going back, ma. So there must be forward. Okay, so therefore, this engine is to make what move? Is to make the plane move, ma. Therefore, the plane moves forward. Okay, right? So this template you can use for any example right? You just need to change the objects only. Okay, you change the objects here, change the direction, change this direction as well, and then change this direction, and then change the object, change the direction, like that. Okay, so for example, if let's say now they're asking you to explain when the bullet shoot out from the gun, why does the gun go backwards? Okay, so you say the bullet is ejected forwards at high velocity. This produces a large forwards momentum. According to the principle of conservation of momentum, there must be an equal but opposite, so backwards momentum. Therefore, the gun moves backwards. Okay, this is how you explain all the momentum explanation question. Okay, 4 marks, easy. Okay, done? This one? All done? Okay, now can I move on already? Or haven't done yet? Yeah, I go on to the next question. Okay, now let's look at question number 6. It's also another motion graph question. Okay, probably this one will be the last question already for today. Yeah. All right, question number 6. Now, figure 6.1 and 6.2 shows the motion of 2 objects. Okay, M and N. Okay, imagine there are 2 cars, right? There is a Malaysia car and there is a Nigeria car. Okay, M and N, right? Malaysia and Norway lah. Okay, Norway, right? So the OPQR, this graph, PQR, this is the graph for the Malaysian car for M. Okay, and then OQT, this one, this is the graph for the Norway car, N. Understand? Right? So 2 cars they both start moving together. Both start moving simultaneously. As you can see here, both also start from 0 together. Okay? What is the acceleration of Malaysia in the first 5 seconds? Okay? So here, first 5 seconds. Again, SVA ma. Go down, gradient, go down, gradient. Up, area. Okay? Where are we now? We are given the V. We are given the velocity time graph. Okay? So we are finding acceleration. So they ask us to go down. So that means we need to find the gradient for the first 5 seconds. Okay? Gradient for the first 5 seconds. So again, y2 minus y1 over x2 minus x1. We can go 12 minus 0 over 5 minus 0. Okay, so 12 divided by 5, 2.4. ms negative 2 for acceleration. Okay, sketch the acceleration time graph for both M and N on the axis in 6.2. Okay, so now we have to convert the velocity time to acceleration time. Okay, with let's draw the Malaysia car first. Okay, the Malaysia car. We already know that the first 5 seconds, the Malaysia car acceleration is 2.4. So let's start there. Okay, for the first 5 seconds, the Malaysia car is 2.4. Okay, now for the next 10 seconds, meaning from 5 to 15, what is happening here? You look at the velocity. The velocity is 12, 12, 12, 12, 12. Means that he's maintaining the same speed. Okay, he's maintaining the same speed. So same speed means you are not going faster, you are not going slower, so your acceleration is 0. Okay, your acceleration is 0. And 0 acceleration, you need to draw out. You cannot say, oh, 0 there, I don't want to draw, nothing to draw. No, you have to draw also. Okay, 0 also need to draw. Right? Okay, then for 15 to 20 seconds, it's going down. Going down, there must be deceleration. It's getting slower and slower. So what is the deceleration? Again, we can calculate the gradient. Right? So the gradient going down is, let's take y2 minus y1, 0 minus 12, divided by x2 minus x1, 20 minus 15. It's negative 12 over 5, so it's negative 2.4. Okay? So the last 5 seconds, it is negative 2.4. Like that. Okay? Here, there. Negative 2.4. Okay? Now, let's do the N car, the Norway car. So for the Norway car, right, it's just one straight line increasing velocity. Means that it is constantly accelerating. The acceleration is constant since it's just one straight line up. So how much is it? Again, we can find the gradient. Yeah, find the gradient of this line. So this will be 16 minus 0 over 20 minus 0. Okay, so 16 minus 20, 4 over 5. 4 over 5 is 0.8. Okay, so for the Norway car, it is 0.8 all the way. .8 all the way to 20. Okay, this is how you get the acceleration time graph. Yeah, you should label also lah. You say this is M and this is N. Especially if your exam, you are using the same color, then you should label also. Especially that. But of course, try to use different color lah. Black and blue or red. Okay. All right. Next one. Is M, Malaysia, in front of Norway, or Norway in front of Malaysia, or both moving side by side when the time t is equals to 15 seconds? Okay, so here at this point, I don't really care about what happens after lah. Okay, so we can cover up what happens after, doesn't matter. Okay, but at 15 seconds, right? What do you think? Do you think Malaysia is in front of Norway, or Norway is in front of Malaysia, or they are both side by side? I let you guess first. Guess first, then I review the answer. Which one do you think? Malaysia is ahead, or Norway is ahead, or both side by side? What is it? You try to guess which one is ahead? and Norway? Okay, right? So let's see. Okay, how do you tell whether someone is ahead or not? If let's say you're not watching them move, okay? You're not watching them move, right? How can you tell whether someone is ahead? You can look at their total distance traveled, correct or not? Because if let's say both of them start together, and one person moves 30 kilometers, the other person moves 25 kilometers, of course, the person that moved 30 kilometers will be ahead, right? So what we need to compare, right, is we need to compare their distance traveled. Okay, we need to compare their distance traveled. And what exactly is the distance traveled? Back to our SVA, we want to find distance, you got to move up. That means you need to compare the area. Okay, the distance traveled is the area. Understand? So compare the area of the two. Let's see. This is the area of Norway. Okay, this is the area of Norway. And this is the area of Malaysia. So now is it obvious? Yeah. Malaysia's distance travel is much bigger than Norway's distance travel, right? Okay. So that's how we can tell that Malaysia is ahead of Norway. Okay. That's how we can tell M is in front of N. Okay. Because this area is bigger than this area. Yeah. Okay. Of course, your answer, you just need to write this. All these extra things, right, is for you to refer. Just in case later you want to come back to this question, then you don't understand, why the time the teacher say M is in front of N one, then at least now you know. You can write down something. So in the end, they still ask you to determine what is the distance between M and N at 20 seconds. So again, it goes back to distance, right? So distance again means you find the area. So you just find the area for M and N, you get both of their distance travel, then you see what's the difference lah. The difference will be the distance between M and N, no? Correct not? One person travel this far, one person travel this far. This is the distance between them, no? Okay, so let's do M first. Area M first. Okay. Now, area M, right, is a trapezium. Okay. If you don't know or don't remember how to calculate the area of a trapezium, you could always just go with triangle plus rectangle plus triangle. Nothing wrong with that. You still get the same answer. Okay. But if you really want to do trapezium, all you need to do is take the long and the short one and ask them to share. Okay. Meaning add together, divide by 2. Ask them to share. After they share already, basically they are the same length already. Then you can multiply the height to get a rectangle area. Okay, so A plus B divided by 2, you have 10. 5 to 15 is 10. And then B is 20. So 10 plus 20 divided by 2. Okay, multiplied by the height between them, 12. Okay, so 10 plus 20 is 30. This one 30 divided by 2 is 15. 15 times 12 is 180. Okay, it has traveled 180 meters. Okay, what about N? N is just one giant triangle, right or not? One big triangle. So the triangle the base is 20, the height is 16. So it's just half times 20 times 16. Half times 20 is 10. 10 times 16, 160. Okay. Now, of course, this is not the answer. Don't leave the answer like that. So the answer is the difference. So distance between M and N, okay, is 20. That distance between M and N is 20. Okay. So, sorry, meters. Okay, so that will be all the questions we will be doing today. Okay. So later on, right, like I said, they'll probably give you what is it? N? Oh, sorry, just now. I don't know. Okay, so later on, they'll probably give you answer. Okay, I think they will provide a link at the website lah. I'm not completely sure, but most likely they'll provide a link at the website. Okay, so go there and get the link and get the answer, and you can try the remaining questions. Okay, you can try remaining questions. At the bottom here, there are some objective questions, right? So I will give you the answers for objective questions first. Then at least you can do this first without needing the answers yet. So I'll give you these answers first. So you can write down or take a picture. Let me write down 1B, 2A, oops, 3B, 4B, 5B, 6C, 7D, 8B, 9C, 10C, 11C, 12A, 13B, 14B, 15C, 16B, 17A, 18B, and then 19C, 20B, 21C, 22C. Okay, yeah, you can write this down or you can take a picture of this, take a screenshot of this. Yeah, so you can do the objective first before without waiting for the answers. Okay, so any questions for this seminar? Any questions up to here? All right, so if there are no questions, then that will be all for this seminar. Okay, thank you for coming on a Sunday, right? So for those that haven't have your exam yet, then wish you good luck lah. For those that have your exam already, then yeah, you are using this for your SPM lah. Okay, right? So I will see you guys again in the future. Okay, bye-bye. Okay, thank you, bye-bye. Okay, if you have any questions that you want to ask, right? Because this will be recorded. If you have any questions you want to ask, you can go to my Instagram, okay, and find me there. This will be my, oh, sorry. That's my personal Instagram, wrong one. You're going to go to this one, Weien Physics, okay? And there you can ask me any questions you want, all right?